Hello, this is section 1.6 and we're going to discuss what's called parent functions. And the idea is to know the property of these parent functions because we're going to plug other functions inside of them. And if you understand about the parent functions, then you're going to know about their offspring. You know, the things we get when we plug another function in, which is called composition of functions. And we'll talk about that in a subsequent section. So we want to know the important properties, and that we mean the graph. But the important properties, you want to know the x and y intercepts, the range, the domain, where they're increasing and decreasing, the minimums and maximums, whether they're even, odd, or neither. And if you know these things about the parent functions, then when we combine them with other functions, you'll understand those a lot better. We're not going to do a lot of problems today. In fact, it'd be very, very few. The idea is just to go over the properties, and some of this is review. So we've talked a lot about lines. But it's good to go over this. The domain of the function is the set of all real numbers. You can plug any number into this, and you can get all possible numbers back as long as the slope is not equal to 0. If the slope is equal to 0, what happens? If m is equal to 0, what you're going to get is a horizontal line. So let's say we have an example like y is equal to 3. Then the line looks like this. It's going to be the line y equals 3. And you see that the range is just going to be equal to that point 3. That's all we're going to get. That's all the range is going to be. Okay, the graph has a y-intercept of 0, b, and we get that by plugging that into this equation right here. Plug 0 in for x, you get b back. The graph, if m is not equal to 0, it has an x-intercept of minus b over 0, and I'll show you how you get that. I'll just do the quick equation solving. Let me do this down here, turn that off and do it here. So we're going to have, if we have y equals mx plus b, to find the y-intercept, the x-intercept, you set that equal to 0. So then we're going to solve mx plus b is equal to 0. Subtract b from each side. We get mx is equal to minus b. And then we divide each side by m. Those m's cancel, and we're going to get m is equal to minus b. We're going to get x is equal to minus b over m right there. And that's what we're saying. That's what we said right here. Okay. If there's no b term, so the L is equal to mx, that's an odd function because the exponent is odd, just 1. If L of x is equal to mx plus b, where neither the slope nor b are 0, it's neither even nor odd. This line here is an even function, and one way to see that is that, remember, when you have a constant, it's really a constant times x to the 0. 0 is an even number, so that's why that's an even function. There's no minimum or maximum, unless if the graph is like this. And if the slope is not equal to 0, this is what the graph looks like. And you can see that it's decreasing when the graph goes this direction. It's decreasing everywhere. And then over here, the graph is increasing everywhere. Okay. So this is about the most complicated one we're going to look at. It has a lot of properties. We've looked at these already. So the squaring function is y is f of x equals x squared. You know what the shape is. It's a parabola. The domain is a set of all real numbers. You can square any number. You get back, since squares have to be 0 or negative, you get back only non-negative numbers. So you can't have a square being negative. The function is even because all the exponents are even, just a 2. X and y intercepts are at 0, 0. I think that's pretty clear. The function is decreasing over here until we get to 0. And then it starts to increase again. So it starts to increase over here. So that's what we're saying here and here. And there's a minimum down here. I think that it's the lowest point on the graph. And that's what it looks like. So the cubing function is another important one. The domain and range are real numbers. You want to remember that unlike a square, a cube can be negative. So if we cube, let's say minus 2, we get minus 2 cubed. And that's going to be 3 minuses times each other. So minus times minus is negative if there's an odd number of negative signs. So this is going to be negative, because there's 3 negative signs, 8. Okay. Again, the intercepts are 0, 0, both the x and the y. It's odd because the exponents, you can see, are just odd. The graph is increasing everywhere. It's going up here, and it continues to go up over here. Okay, and that's why there's no maximum minimum, because it's always increasing. But if you look at the graph, there's no low point, and that's what the graph looks like. Now, just as to point out that if we have something, if we plug something into the cube, like something like, x minus, sorry, you know what? If we plug this over here, we're going to get the same kind of graph. We would get a graph that looks like this. Minus 2 would be 0, and the graph would go up like that. So it'd be similar. Okay. So I want to look at the square root function. And again, the domain is going to be the set of all positive numbers and 0. We've talked about that before. Remember, the rule is one of the I think it's the #1 rule of Math Club is that you can't take a square root of a negative number. The range is going to be the set of all negative numbers. This graph keeps going up, and eventually it's going to hit every number. So the range is going to be the set of all non-negative reals. The graph has intercepts 0, 0, x and y. The graph is increasing. If you notice, like, it's always going up, even though it goes up slowly. It's neither even nor odd because you can't plug a negative number in. And the minimum is 0, 0. It's the low point on the graph. And that's what the graph looks like. And you can get these graphs by plugging them into Desmos or a calculator. Okay. The reciprocal function is what it says. You plug in a number, you get its reciprocal. So if I plug in 3, for example, I'm going to get 1 over 3. So that's what it means, the reciprocal of 3. The function is odd. It has an odd exponent. There's no x or y intercepts. Notice it doesn't hit any axis. The graph is decreasing everywhere. It starts really close to 0 over here, and then it goes down. Then it gets really steep over here. And it's decreasing here, right here. Okay. Now, since this part of the graph doesn't connect to this graph, there's no point where the graph is going up. That's why it's always decreasing. It looks kind of weird. And that's what it looks like. And there's no max or min because there's no low point. So let me write that here. No max. I should have included it, but I didn't. Or min. Okay. Two more functions. This is called the step function. And we're going to use this to define functions which are called piecewise defined. That means they have different different properties, and they're broken apart. They're in pieces. So that's why this is called a piecewise function. Now the way to write this is you use this notation. It's the greatest, and this equals the greatest integer less than or equal to x. So if I take the greatest integer less than or equal to 5, I get 5. And if I take 4.9999 with a 9 at the end, I'm going to get 4, no matter how much bigger than 4 it is, as long as it's not 5. The greatest integer less than that number is 4. The greatest integer less than or equal to 5.1 is 5. And you can see that on the graph over here. If we plug in a number a little bit bigger than 1, it returns 1. If we plug in a number a little bit bigger than 2, it returns. The x and y intercepts, again, are 0, 0, just to point that out. The graph of each section jumps, and it never increases because you notice these points aren't connected. Notice that this point is part of the graph, but the endpoint over here is not. That's actually the point up here. It's neither even nor odd, and this is what the graph looks like. So it's constant, even though it does increase, sort of, if you look at it that way. It doesn't. There's no interval in which it increases, so it's just a constant function in different pieces. Okay. It's neither increasing nor decreasing. Okay. And the last function we have is the absolute value. And the absolute value is the distance of x from 0. So it's always positive or 0 because distance has to be positive. So for example, right here, if we plug in minus 4, take the absolute value, you get 4. It's the same as if you take the absolute value of 4. Absolute value of 0 is 0, because the distance of 0 from 0 is 0. The domain is all real numbers. I can plug anything in. But since I only get positive numbers, or 0, the range is going to be non-negative, 0 to infinity. It's an even function because if I take the negative number, that's the same as I take the positive. Absolute values makes the negative positive. So as above, if I take f of minus 4, I get the same as if I take f of 4. So that's true. So that makes it an even function, even though it doesn't have an exponent. It looks like it doesn't have an even exponent. It's decreasing over here. The graph is going down, and then over here the graph just goes up. You can tell that. And then right here, that's a minimum, 0, 0, and the x and y intercepts are both 0, 0. And that's what the graph looks like. So again, we want to understand the properties of these parent functions, so when we plug other functions inside of them, we have a better understanding of what those functions look like. And we'll see examples in subsequent sessions. Okay, so thank you, and that's it.